and we're live, so it 5, 10, no, almost at 1960, funny, 19. Happy birthday, Bill. Okay, so today's objective really is finding angles from right triangles. Okay, finding angles from right triangles. And what we're going to do is we absolutely must have the inverse button. It's the inverse, because if you're going to find the angle, you need the sides to get the angle. So the inverse button. Okay, find the inverse button. Find sine -1. So right now, find sine -1. Find the cosine -1, and find the tangent -1 buttons on your calculator. So they're in blue. If you find them, yeah, absolutely. So here they are. They're in blue. Sine inverse, cosine inverse. I'm going to say inverse. I'm not going to say -1. And tangent inverse. Okay. So, but Cameron's right. To get to these buttons. You have to use the blue buttons. So I'm just going to have to push the second and something, clear, or the second and something, or the second and something, okay? But it depends on what we have. So first of all, in example 1, I said let's just try the calculus. So we're going to go sine, just push this, so second sine, okay? Once you just push that button, second sine of 0.5, and we get 30. Now that's an angle. That's 30 degrees, okay? So we found an angle. So let's say theta, because that's our symbol for angle, is 30 degrees. Okay, that was easy. Everybody agree? So what we're finding is an angle. So this inverse button finds the angle. So whenever you push the inverse button, you're going to find an angle. I'm going to say that again. Whenever you push this inverse button, you're going to find an angle. Let me say that again. Whenever you hit or touch or push the inverse button, you're going to find an angle. So if you have to find an angle, which button do you push? The inverse button. Absolutely. And it will always give you an angle. Not a side, but the inverse button will always give you an angle. Everybody got it? Okay, now, so example 2. Find theta, or find the angle. We're going to find the angle. Okay? So if I want to find the angle, what button do I push? Inverse. So I'm just going to have to go sine inverse of 1/2 equals my angle, right? That's what I'm saying. So if I hit this inverse button, I'm going to get the angle. So go ahead and try that. And what do you get? I'm hoping 30. I'm hoping 30 because these two are the same question. These two are the exact same question. One is saying to find the angle, you push the sine inverse, and when I did the sine inverse of 0.5, I got 30, right? They're the same question. Okay, so the angle is 30. So whenever you push the sine inverse, whenever you hit the inverse button, you find the angle, right? So I did that. I found an angle by pushing sine inverse of 1/2. I'm being really repetitive, aren't I? Right? Because I've learned. Say it another 6 times, and maybe it's going to sink in. So let's look at example 3. I want to find theta. Okay, now let's do some trigonometry. Here's my angle. Always start with your angle. Always start with your angle. Right there, start with angle. So what's the name of this side? That's the opposite, right? What's the name of the 2? Hypotenuse. So if I'm going to use the opposite and the hypotenuse, I look up there, which one is it? So I'm going to go, okay, sine theta equals the opposite over the hypotenuse, right? Right? Well, let's fill in some things. Well, I don't know what theta is, but that's what I'm going to find, right? So I'm going to go, okay, sine theta equals the opposite, which is 1, over the hypotenuse, which is 2. Well, it's the exact same question as that, isn't it? It's exactly, we know it's 30 degrees, right? And if I did that, I'd say, okay, well, if I want to find the angle, what button do you push? The inverse, right? So I'm going to go, okay, I'm going to say, okay, sine inverse of 1/2, and I get theta, which is 30 degrees. Okay, awesome, right? So now we know how to find an angle we push the inverse button. Okay, so now let's go down to, am I going too fast, Derek? Question. Now it's not always sine, is it? It depends on what you have. So let's look at example 4, okay?
30.
Yeah, you're right. You knew it was 30. Good for you. That's exactly.
But no, but it doesn't make sense because x to the negative to the third power.
X over 2x is 1/2.
Yeah, but then what does the length of the adjacent mean? 'Cause it doesn't match up.
No, it doesn't, because you don't know the adjacent, but we can find it. Okay. Okay, let's look at example 4. Find angle A. So if I've got angle A, right? What is the name of the 15? What's the name of the 15? Figure it's the opposite, right? What's the name of the 8? Adjacent. So instead of using sine, because there's really 3 of them, right? Let's use one of the others. Okay, opposite adjacent. Which one is it? It's got to be tangent, right? It's got to be tangent. So, all right, tangent of theta is equal to the opposite over the adjacent, right? We're going to pick tangent because we have both the opposite and the adjacent, right? So, okay, now I'm going to go tangent of theta equals, so the opposite is 15 and the adjacent is 8, right? Okay, I need to find the angle. What button do you push if you need the angle? Inverse, right? So I'm just going to go tangent inverse of my 15 over 8 is equal to my angle, theta. So I'm just going to use my calculator. I can do that. Okay, so I've got to use my blue. I'm going to go tan inverse, right? I got to use my blue button. So I got my tan negative 1 equals my 15 divided by my 8, right? And I push enter, and it's about 62 degrees, or 60, if you want to be accurate, 61.9. You guys okay with that? 61.9. Okay. So angle A is 61.9 degrees. Okay, 2 thumbs up, right? Okay, am I doing okay? If you're not there, you can be honest. If your thumb's down, it's okay. Thumb sideways, okay. But let me see, where you at? Okay, all right. So let's turn the page, okay? So, example 5, my favorite triangle, triangle PIG, right? So in triangle PIG, we have to solve it. So Isaac, that's where, you were kind of off the hook because you weren't here. But if we take a look at PIG, and I want to solve it, I have to find everything I don't know. I don't know angle P, I don't know angle I, and I don't know little I, which is PG. I don't know little I, okay? Those are the 3 things I don't know, okay? I need to find all of them. Well, it does not matter which of the 3 you pick. It doesn't all, okay? Beth Ann, what do you want? Do you want to find P, I, or little I?
Little I.
Little I, okay. Now, we're going to have to use Pythagoras Theorem to get little I, because we don't know any angles, right? Does that make sense? We're going to have to use Pythagoras Theorem because we don't have any angles, but that's okay. That'll work, right? So we'll go little I squared plus 12 squared equals 16 squared. Does that make sense? If I had an angle, I could use one of those, okay? Because I use an angle to get a side, right? I use an angle to get a side. I don't have an angle, so I'm going to use Pythagoras Theorem. I can do that, okay? I squared plus 144 equals, I don't know, 16 squared. Hold on, clear. 16 squared. 256, right? Minus 144, I squared equals, I know it's 256 minus 144, 112, okay? Square root, so I is equal to the square root of 112, because that's how I get rid of the square, right? Go square root of 112, and I get an answer of about 10.6. Little I is 10.6. Okay, so let me put that in. I'm going to add that to my drawing, and I'm going to have that one down. Okay, so there is my 10.6. Okay, we got that one. Okay, now we have angle P or angle I to solve for. Okay, and again, it doesn't matter. Brett, what do you want? Angle P or angle I? It doesn't matter to me. Angle P. So Brett's going to pick angle P. Now you can use any of these 3. I suggest not this one because it's not exactly, I mean it's 10.6, right? But it's not really exactly 10.6. These are good numbers. You guys agree? So let's use the good numbers, okay? 12, 16. So I'm going to use my 12 and my 16. And you always start with the angle. So what are the names? So if I use angle P, what's the name of the 12?
Opposite.
Opposite, you guys agree? Opposite. Because if I was standing here at the lake at P and I threw it all the way to the opposite side, that's where the rock would go, right? And what's the name of the 16?
Hypotenuse.
Hypotenuse, okay? So if I have opposite hypotenuse, I'm going to use one of those three. Which one? Opposite hypotenuse.
Sin.
Sin.
Sin. Sin's for church, but goes for sine, okay? So
Sine.
sine it is.
I don't care. I like sin.
All right. We're going to go sine of P. Sine of P, right? Sine of P, because that's my angle, is equal to my opposite over my hypotenuse, because that's my sine. Instead of theta, theta represents my angle, so P. So I've got, whoop, yeah. So I'm going to go sine inverse of my opposite, which is 12, over my hypotenuse, which is 16. Okay? So what I did was this. Abby said it. She goes, I got to do inverse. Yeah, because we need to find the angle, right? So we went to sine inverse, because we're the angle of the opposite of the hypotenuse. What did you get for an answer? Probably about 30-something, maybe?
48.5.
48.5? Okay. Sine inverse, you're probably right. Sine inverse of 12 divided by 16. Yep. Nice job. 48.6, okay? So angle P is 48.6 degrees, okay? This is pretty easy, isn't it? So let me put, yeah, I'll wait for you.
What are you putting in the calculator?
Right there.
I can
So I hit, Cameron, I hit second.
okay, that's what I'm doing wrong.
Okay,
Okay.
I hit the second. You got it. It has to have,
You're the one who
see
did
this
the
little
sin.
negative one, Cameron?
Yeah.
Has to have that little negative one, that gets the angle, okay? That's my angle button, right?
Yeah.
Okay, then, almost done. What about angle I? Angle I is easy.
Don't we just subtract it? From
Right, because these two angles add up to 90, right? Don't these angles add up to 90? They have to, because the whole thing's 180. So angle I is just going to be 90 degrees minus my 48.6 degrees. Okay, so 90 minus my 48.6.
2.4.
And I got about 41.4.
Or wait, no, whoops, I was going off 90.
That's okay. What do you think?
Easy.
Pretty easy? Okay. Now, is this stuff used in the real world? Heck yeah. Here's a pretty close to real world problem. Okay, let me slide up. Okay, wheelchair ramps are a state law. Okay, and so if it's less than 6%, you're okay. 6% or less, you're okay. Anything more than that, and poor grandma can't get up the ramp, right? It's kind of sad, right? So the wheelchair ramp thing came effect, believe it or not, only about 20 years ago, which is kind of sad. Before that, they were curbs. How do people get up a curb with a wheelchair? Isn't that sad? Yeah. So I've got a wheelchair ramp. So the ramp looks something like this. The height of the ramp is 8 inches, and the length of the ramp is 54 inches. Okay, is that?
Not
The length of the ramp, right?
the length. Would that be the?
That'd be the ramp. So I know this. A lot of kids get. Derek, you're not the first one, but the ramp itself is there, right? You guys agree? That's the ramp. That's
upward
54.
angle.
See, this one you wouldn't even see, right?
That's like the concrete underneath.
Yeah, there's concrete underneath. Does that make sense? So here's my angle, okay? So if I want to find this angle, again, same thing. Start with the angle, and what are your names? So the 8, what's the name of the 8? It is the opposite. Here's my angle. That's got to be the opposite. And the ramp would be what? Hypotenuse. So opposite hypotenuse, which one is it going to be? Sine, right? Or sin. Right? Okay. So I'm going to go sine of the angle equals the opposite over the hypotenuse, right? What button do I need to push? Inverse, right? Inverse, what'd you get?
8.51.
Oh, bummer, we're over, which means I had to rebuild our ramp, okay? So Isaac already got it, sine inverse of 8 over 54. Sine inverse of 8 divided by 54, and yeah, I got about 8.5 degrees. So we're going to have to rebuild that ramp. it will not pass city ordinance. That makes sense? So no, tear that ramp down.
Did they actually check that?
Yeah, true story. Not the ramp, but